more
This conference will now be recorded.
Okay, for more analysis about this thing. Probably we are trying to go as deep as possible in our sessions, but still, and if you have time and if you have patience and if you have interest, I found this website and the examples in this website are really good. So you can go through this website, sir. Okay. Okay. Usually, and also this is one thing, and also one more thing which I prefer is okay. Other whether right, some basic websites are there, but they just have only very basic problems. They don't go to this extent of explanation. Okay, like right, mention the names, but still you have an idea. Tutorial point or probably Java T point. They're really good for fundamentals. But if you want to go deeper, probably this is more like a textbook. This is not a website, okay? And this guy had written, if you go down, I'm just showing you so that this because you need to know references also, so that might help you. This is might be this guy had written Scala cookbook and how I sold my business and functional programming simplified. This guy is someone, he's author of many books here if you see, and I found this website is some really wonderful actually. No, because even you need to, this is useful for you, so I'm trying to bring to your notice so that also other websites are fine, sir. This is I usually prefer we go through not just one website, but I'm just trying to give you the bibliography which we generally I refer for your sessions. This is another one which I generally prefer because you have the whole API in this sense, and apart from API, you see a lot of times we directly go to this official website of Scala where you have really the kind of the point presentation is totally different here. There is also one more. You can try this. And next one, this anyhow, all of you know this. The freshers usually like these things, Java T point or tutorial point, all that. So this is simple analysis, sir. Okay. Now I am switching to my topic now. Yesterday I was talking about word count, sir. Probably you might have an idea about word count, and probably we have finished that word count as well successfully in yesterday's session. And we have seen applying a couple of transformations here. This map by this group by and this map values. These are all transformations. And then one more thing is when you go to the Spark terminologies, map is more or less it's a narrow transformation, and the group by, instead of group by, we come up with something called group by key, which is a wide transformation. Okay. Anyhow, when I go to the Spark again, I will bring into your notice very clearly like what is the exact difference between narrow and wide, how the shuffling occurs. We'll see that with the practical use case. And also the same program which we tried yesterday, this is an array. Yesterday, while discussing something, I told we can map an arrays here, right? Because this returns split method returns array of string actually, string array otherwise. So that on that we are applying map, and also I again explored little more today. When I had done that, I got to show you this also. Even array is an implementation class for this indexed sequence. See, okay, right. I just muted, so please don't mind. So now let me just show you here. Collections in Scala. When you look at this, sir, just all of you observe here. The immutable collections. Now we are in that discussion. We didn't still switch to the mutable. But anyhow, if you have idea about one type, it's almost same for other types. You see now, from here onwards, I don't think we have. Can you see there? This is, see here, immutable. And if you see here, array is an implementation class for indexed sequence. Apart from vector, numeric range, string and range. Okay, array is also an implementation. That's why, as we know, right, traversable and iterable and sequence have some built-in methods, and those methods and even indexed sequence also have some additional methods. And all those methods from the parent traits are inherited to these subclasses or the implementation classes. So that's why even we are able to apply map on this array. Yesterday we were talking that scenario. Okay, so that is also one more important point I would like to bring to your notice. So next after that is uh, again one more small example. The same program what I have tried to do with string. Now again in the next example I try to do it with list here. If you see there, I took a list here directly. On that, I am applying a flat map to split this. Instead of applying split from string, here the difference in the program is I had applied a split on string. Split method is there in string as well. So I have applied that on that, and then on top of that, we applied some transformations. And now if you see, I took list directly. On top of that, we applied a transformation, which is flat map. And that flat map, what it does, it iterates the every element here. How many elements are there here? I have three different strings. Bitty bought a bitter butter, that is one string. To make bitter butter, to make a bitter butter something, that is second string. But butter is better, that is third string. Now, what this flat map will do, flat map or group by or filter or these are all iterators. I told you this. These are all iterators. They will try to iterate each element and based on their type actually, if it is flat map or map, they try to apply an operation on each element. That's what this map will do. And if it is grouped by, it will try to group elements as per that key which we mentioned. Okay, that's what group by does. Map values we have seen, it will extract all the map values from a map instead of keys. Right? Map has keys and values. It will try to extract keys, values and try to do some apply again something, some kind of functionality on that. And everywhere you can see, sir, sometime back somebody, we have a question like how this inner, right, this is these are all function composition. If you see function as a parameter to another function, you can see that lambda functions everywhere we are seeing as parameters. Means that's one more beautiness of Scala. And now what this flat map will do is it will try to iterate every string. On top of that, again we are applying a string now, and this we are doing through what is this a transformation, not directly through a string. Okay, so this is another style of doing. Usually we try to do this kind of scenarios in Spark actually, and the code also almost remains same. A few changes will be there from direct Scala to the Spark Scala, but almost it is same. Okay, and other stuff is same. We know we have done it yesterday, and we didn't test the program yesterday because already it's too late for us yesterday. So what I want is would you please test this program now, folks? If you don't mind, can you please test it with the list or with string is up to you, sir. Which one you want to choose is up to you. So please try it, sir. Okay. Please test it. Maybe I can run this quickly. I can copy this and paste here. And you can see there now. This is perfect program for giving us word count. Inside this map, we are adding the advantage of map, right, sir? We can avoid duplicate keys. That words might be repetitive, but still the greatest advantage with map is when you add something to a map as a key, that duplicate is removed. That is also advantage with maps. Okay. Right. Anyhow, we go for a detailed research on map. Okay. For now, let's focus on sequence and its implementation classes. Okay. Now, when you run this, right, you have observed the output. I don't see it is different from yesterday's result. It's both are same, but we have a slight change from yesterday's program to today's program. That's also. Please test it. Then we will switch to the next program. And please confirm, sir, once you are done testing, please confirm so that I can switch to the next topic. To copy and paste this code, definitely I'll do it, sir. I'm just copying and pasting. Maybe if you think it's useful, please use it. And count is a map here. And one more thing I would like to tell, I thought to discuss today is the difference between a normal collection and a generic collection. Right? There are different, these two types of collections exist. Okay. If once you are finished, just confirm, then I will just quickly discuss to that topic. It doesn't take much time. Sudarshan, sorry to ask you, you know Telugu?
Yeah, Manohar. Yeah.
Okay, thank you, thank you. Because we were
Yeah,
chatting in Telugu, that's why I tried to ask you. Okay.
yeah. I'm from AP only. Yeah.
Okay, sir. There is something, a quick example for us, sir. The difference between a normal collection and generic collection. Here, right? All of us know that, right? Everywhere I am applying val here. Reason is because these are immutable collections, sir. This is actually a standard. Remember, this is very important thing when you go to the coding in Scala. As we are implementing, dealing with immutable collections, we cannot modify them internally. Okay. So whenever you try to extract something from existing immutable collection, what happens is the result again you have to initialize to another variable, not to the same. It's not possible because because it is immutable, it won't get modified. Got it right, sir? That's why always what people recommend is when you are dealing with Scala, when you try to extract something from an immutable collection and that result, whatever it is there, you try to initialize to some other new variable rather than trying to modify the old variable, existing variable. That's actually a standard approach. And also making sure all these variables are declared as val is one more standard approach. Because even if you don't put, if you put var also, we don't have much use to that because as these are immutable, you cannot modify them. So var is recommended if you want to modify something, and that is the time when we declare var. So mostly when you look at the code, you try to put val because the reason is simple. We are trying to deal with immutable objects, so that val is best scenario, best thing to use rather than var. But var is recommended only when you want to make some change. That too, var is more applicable with mutable elements rather than immutable elements. difference. Okay, so this is a quick analysis. Second thing, right, sir. When I put a cursor on this, you see, sir, I didn't declare. No, let me just do one thing now. I'm removing all this to explain that generic difference. We don't need this much code. Okay. See, this is a list and list of strings here. Suppose I can declare this variable with data type also, right, sir? In Scala, we have two approaches or two ways to declare a variable. One, if you want, you don't need to declare variable. Scala takes care of the type because Scala is both. In Scala, we can have dynamically typed thing and also static type. Means if you want, you can declare a data type. If you want, you can skip a data. If you don't declare data type, your Scala takes care of the data type. If you declare data type, then Scala ignores that. Here in this case, I didn't declare data type. Means what? Means Scala automatically declare the data. How it is declaring? If you put cursor on that, you can see there. It is saying list of string. List of string. Suppose if I put all integers in this, it will take list. It will say in list of integers. Very well. Suppose I have a string and integers, then it will say list of any. Correct, sir? We have seen the scenarios. The casting, how casting applicable in list, okay, or in these kind of collections. The point is, suppose that is a normal collection. Means based on my data, automatically the type of this reference is changing. Okay, that is a normal collection. Generic means what, sir? Here I say list of string here. Okay. Now, when I say list of string, at any time, you have to declare a list with only string data. You are not allowed to have what in this, sir? You are not allowed to have any integer in this comma. Suppose I put 1 here, sir. Immediately you are seeing an error. Can you see there, sir? You are seeing an error. Why? It clearly saying what is the type mismatch found int required. So it's saying found int required string. Why? This is actually a generic collection. Whenever you declare a type with a specific data to be there in that, then it's a generic one. The advantage of generic is it makes your data homogeneous, not heterogeneous. What generic collection do, sir? Generic collection make your data homogeneous. Also, you clearly tell what type should be there in that collection. If it is string, then you have to put only string in that. If it is int, you have to put only integers in that. And if it is double, you have to put only double in that. At least that the upcasting is allowed. Okay, that is fine. Okay, that bound to the rules of casting. Based on that, you can put the data right there. So this is actually a generic collection. And now you don't mention any generic collection here. Okay, you don't mention any type. Okay, and just leave it like this. This becomes a normal collection. However, what's happening is internally, even your Scala is using generic collection here. Why? By depending on data, again it is trying to what declare the type here. Even this is also a generic. If usually in Java or any other languages, this type is not declared. If this type is not declared, it becomes what? It becomes a normal collection where it becomes heterogeneous. But in this case, it is not heterogeneous, as you are saying that this is a list of string. If you find it like this, then it becomes what? Homogeneous, and it is it's a pure generic collection. Okay, and if you explicitly declare, that's much more what is that static type. Okay, much more generic. Now again this changes, depends on your data in the list. So still I cannot say that this will be exactly a list of string. It might be a list of integer, or it might be a list of any, it might be list of double, it might be list of something else also. And it keeps changing. Suppose now if I say list of string, then at any cost it allows to declare only string type of data in that. Doesn't allow any other types, sir. Are you following, sir? So this is simple. This is a pure generic. and generic usually is heterogeneous, sorry, homogeneous. And the advantage of this is it is strictly typed. So whenever you have a generic collection, the advantage is one thing, sir. The data is homogeneous. When data is homogeneous, we can avoid casting issues. Usually when you have casting issues, it leads to the typecast exception, what we call class cast exceptions. Usually we come across such exceptions in the real-time code. When you don't have a generic type, when you have a heterogeneous type, the issue with that is we come across issues like class cast exceptions. Are you following, sir? This is one interview question last time, in one company. One guy asked what exceptions you are facing in the Spark Scala code. Then I told him, they are expecting these kind of examples: class cast exception, null pointer exception, array index out of bounds exception, string index out of bounds exception. Likewise, we come across so many exceptions, sir. So the point is, even you need to have some idea about exceptions just to throw on the face of the interviews. Really, we don't exactly remember every time all the exceptions, but for interview it is necessary, sir. Got it right? Okay. So is that clear to you, sir? All of you are good with this? Do you have issue with my voice, sir? Because I see Madhu is having some issue. Is why? So Madhu, I think it's clear for others, sir. What about others, sir? Is voice clear? Okay, might be, yeah, might be Madhu. I think you are having some network issue. So, is this concept clear for all of you? A generic and non-generic or normal collection. Is that clear for all of you, sir? You got the difference, right? Usually, when you talk about generic collections, let me just add few points here, sir, so that the advantage is that if the collection is generic collection, the syntax look like this. Because I want you to be more clear with everything. As we are learning, let's learn in the best possible way. Okay. So now usually what we do, something like val or where we put it. You can also put where, sir. Okay, right. That's how it depends on type of collection. If it is immutable, generally we try to use val. If it is immutable, we try to use where. Okay. But one more important point, sir. Throughout Scala, most of the time, your Scala objects are immutable. And also, the type we choose is val. I don't say we don't use var, because in our code, we have both val and var. Okay. But the vals are more in the code. When I look into the code as well, and when we are implementing a code as well, the vals are more and vars are less. Got it, right? Because we try to keep data immutable as much as possible in Scala. That is what the strength of Scala is. And I taught you the advantage of immutability, right? Multiple objects are not created. Only one object is created and it is shared by all other objects. So that when you try to modify again, what happens? Multiple objects, every time a new object is created. So it is not recommended. Got it. So I have explained that clearly in string scenario. Maybe you can go through that and check it, sir. So it's like this, something like some var name colon, some again your data type. Again inside that type. This is how generic collection equal to you have your object here, something like some list of data like this. If it is, if not list, it might be set. If not set, it might be map. If not map, something else. Map will have key and values, and then you have two variables here, two types, not just one type to that variable. Map of key comma. So this is generic type. Okay, this is a generic collection. This is how it look like. Now, for example, just now we have seen a small example here, something like val some. Okay, you can just take some L1 colon, some list of some int. This is a generic collection, and then list of 1 to 3, something like this. Okay, this is a generic. It is homogeneous, and the advantage here is what we don't have typing, it is statically typed here. When you have that, what happens? You don't have casting issues. Got it right? No, and you have, it is a type, the perfect and technical word here is it is type safe. What is the word here, sir? Whenever you are applying generic collections, we use this word called type safe. What is that type safety here? We don't come across this issue now. There is no such issue like class cast exception because the data is not heterogeneous, and we don't try to compare one type of data with another type of data. Then we don't have that type issues. It is type safe. Like, just a quick example to remember in this scenario is generally, when you are marrying, we try to prefer to marry from the same caste. Why? I'm not against any other caste, sir. The point is just to make quickly understand this. Why? Because when you are in the same caste, we don't have issues. It is type safe, caste safe, so that everybody will approve our, the relation, and we don't have issues. Suppose you try to go for another caste, then what happens? You have casting issues. What is that? Here also, like in real life, even in programming, we have such issues. What is that? Usually when you try to go for other caste, usually it is rare that parents agree. If parents are agreeing, then we are doing explicit casting. And if parents don't agree, means if compiler is not agreeing, then it becomes what? So you have to go for explicit casting. Even if explicit casting fails, it leads to what? Class cast exception. Got it right? Same thing here also. So when you try to have this homogeneous data, then there is a concept of type safe. When you have heterogeneous data, there is no guarantee that it is type safe. Do you get the point, sir? Is that clear, or shall I repeat this one more time? Can anybody say yes or no here, sir? Is it clear for all of you, sir? About others, sir? No, I see Sandeep is saying it. So this is simple idea about generic collection, sir, and I think you got clarity here. Okay. Now I am switching to the next topic, for and for each in on collections.
Sir, one question.
Please, sir.
We have this L1, from there we got to L2, from there to L3, and finally L4. And finally we are printing the sum
Correct.
of each
Correct.
word. Can we
Correct.
sort it anywhere?
Yes, sir, we can sort it. Sorting can be applied because we have such methods also, sir.
I just tried it here, but I can't find out anywhere for any of the variables.
Okay.
Where can we do a sort?
Okay, you didn't find sort. You didn't find sort method, sir. That's what the point you are saying.
Yes.
Okay, something val L3 equal to L2 dot. You can see here, sir. Sort by then we should say something like
Okay, got it.
you can apply something, sir, here. Sort by, can you go for compare to? Compare to means you need another string here. 1 minute. Okay, they were applying this on okay, on an object. Okay, fine, I got it. I'll do one thing, sir. Here, let me try to apply scope me see. No, this is not a. There is one more method. Let me try this. Sort by. I will take a scenario for you, sir. On that
Okay.
actually.
Fine.
I'll take
Fine. Okay.
because for that, if we should apply sort by, we should get an object, and from that object, based on some attribute in the object, we apply sort by. This is good to
Okay.
have. We need to apply case class here. You can see we can use case class or directly we can try that. I will.
Okay.
I'll bring a scenario for you from tomorrow in tomorrow's session. Okay.
Okay, sir. Okay. Thank you.
You can see here, sir. I think you can apply like this. We'll just try like this. Sorted off. You can have this just for your getting into your what is that? This should work for us. This is applicable on sequencer. Even it has to be applicable here. Order dot. Okay. One minute, sir. We'll just.
Okay, sir. I will also try analysis on tomorrow. If not, I'll ask you.
No problem, sir. Anyhow, the question came here, right? I'm just trying to see how they were using the scenario. We will do a good example tomorrow, sir. We'll come up with that scenario.
Sure.
Usually, right, this is how we need a row inside that, sir, or we need an object, at least one object in the list. On object, we apply this with key. That's how sorting happens. So directly, I think we cannot apply sort by. What I'll do is, maybe if you want, I can show you directly now itself. It's not a problem. If you wish, we can take the example and we can do it quickly. Shall I?
No, sir. Let's don't waste time. I will figure it out tomorrow. Otherwise, I'll connect you separately.
No problem, sir. So means we should use a key here. It should be from an object, and we are trying to. I'll tell the scenario how it is going to work, because as the question came here, suppose we have employee. If not employee, student, customer, anything you can take of your choice. Employee has name, salary, then price, some gender, okay, and designation. You take few attributes. Now an employee number also, sir. Suppose my employee data, we will take just 3 attributes. My employee data is like this: 1 comma employee number, name some AAA, comma salary some 1000 like this, 2 comma BBB some 2000, and similarly something like this. Data is like this, and again here I am taking 3 comma CCC comma some 3000, okay, like this. Now when you are applying this, now on this employees list of, right, we have employee objects here. This is a good example, sir. I think it's good to do tomorrow. I'm just giving a scenario how sort by or that these things are work. Now we can sort it in 3 different ways, sir. One, we can sort it by employee number. That is one thing. Maybe I can do one thing. I'll put 1000 here, 3000 here, and 2000 after this. Now if I sort by employee number, what I get 1, 2, 3. If I sort by salary, I get 1000 become first, 2000 second. This record becomes second, and this will be third. And if I sort by this, you get some other order. In this way, we can sort each record of employee based on these attributes. If you sort by employee number, it gives something. If you sort by name, it gives something. If you sort by salary, we get some other order. Like that, the order changes. So that's where we have to pass this employee attribute. This attributes are there, right? This variables, what we call instance variables. If you pass them as parameters, then based on employee number or based on name or based on salary, we can apply sorting. Before that, one employee object must exist. Employee class must exist. For that, we create these objects and we can pass them to a list. On that list, we apply the sort by. Then that will. Is that clear, Bharat sir?
Yes, got it.
So anyhow, I will prepare a problem and solution for that tomorrow. Probably we will do it tomorrow. Now, let me continue. So applying for and for each, right? For anyhow, all of us know this. We have done number of times. Then right, and we don't know about yield, of course. Yield means what is when you apply direct for, what happens is it will iterate every element and then we print it. What yield does is it acts as a buffer, and all your result is stored into that yield variable. It will yield that result into one variable temporarily, and that is returned at the end at a time to this and initialized to this reference. That's what yield does. Yield is more like, we can say, it's a temporary buffer which will iterate the for completely, and then the once after iterating all the elements, those are stored temporarily into I, and that I is finally what is that is the elements whatever that is stored here, that is assigned to the this reference as a whole, not element by element. That is what this bar is doing here. We got it right. I'll just try to quickly test all this one by one. So we'll do one thing. Let's take this and test point step by step. Okay. Okay. Let me just this anyhow all of us know this. We are using a tuple. Yesterday we had a discussion on tuple as well, and we are applying casting to the list directly. So this is a scenario, and we know different types of tuples are there, like tuple 2, tuple 3, up to what I have seen in some documentation is up to tuple 22 are there. Tuple 22. Anyhow, we are using just the basic tuple, which is directly a static tuple here, where we have fixed elements here. So now we can do this for loop. All of us know this anyhow. What is that for I and then first 10, and we have used this number of times, not this first time, something like this anyhow we have discussed this in the very beginning itself. This is one for loop, and this is the basic for which we apply on almost all collections. Usually this is actually a sophisticated for, which is what we call an iterator or iterator, and this is applicable mostly on collections, not on the independent data. So this is one style. Maybe I'll just add it as some style one. Okay, now this is second style, sir. When you do this, what happens here is you don't get element by element here printed, but what happens is this whole for is iterated, and what this yield does is, as I have explained, it will try. It acts as an accumulator when you put yield here. What accumulator does? Accumulator preserves all the data temporarily in one temporary buffer, and that is assigned to the I, and finally that I is returned as what as the total, all the data is initialized to this R1 here. Okay, that's what happens here, sir. 1 minute, sir. Give me a minute. I think I'm almost running out of charging here, but anyhow, let me finish it. I think it will stay for a couple of minutes. Same thing here, sir. You can see on the same yield, we can also apply some arithmetic on that this resultant variable, and even you can see some kind of arithmetic. These are all arithmetic into 2, percentile 2. This is style 2. Maybe these are all, we can assume this as another style of applying for here, sir. Okay, style 2. Okay, there is another third style. Right? We can directly apply for each. Right? When you have this is external for. If you look at this, sir, this is an external for, and your collection don't have any direct relation with for. You pass it as a parameter, and then you iterate it and you extract the data and you print it. But there is another kind of for here, another kind of iterator, which is implicitly available in this collection. If you see this dot for each is not external one like this. This is an internal for each, which is applicable on this collection here if you see it properly. Now what happens here? And also you see, sir, I am directly passing println. I am not printing like println of I. You know what happens, sir? This is as equal to as this one, but this is implicitly what happens, sir, working for this collection or this list. Okay, and even you can also apply a lambda internally. That is another style. I will show that also to you. Okay, so means to iterate data. Just this is just only useful iterating, sir. We cannot apply any functionality. We cannot apply any business logic on this. This will just blindly iterate the data from the collection. This is style 3. One more style for us. Okay. See how many styles are there. But this is coming from the your collection itself, sir. It is not external. This is internal. It's a method, sir. In fact, it's a method available in the collection. Okay. So, and it iterates each element, and just this prints when you pass println as parameter means internally every element is extracted from this collection, that is passed to this print statement, and this print will print it. That's what happens here. Okay. There is another style again. That is what style 4 again. What happening in style 4? We can also apply a lambda on this. You can see, sir. We can apply a lambda. Can you see this now? We are incrementing each element. If you see another scenario, I can continue with this, sir. I don't need this one. I can apply simply first 10. Now you can see, sir, what's happening here. For each element of I, what I can say is I plus 100. Okay. So this will work like this also, sir. Okay, this will work like this also. Let me see if this is printing data or not, because I'm not seeing any print statement here. So if we need to print, we have to pass it to a print also. That's also necessary. Now we can also use a lambda on this internally. Okay, maybe I can do something like this, sir. Probably I can apply a println. Maybe if you expand it, it's easy to do this stuff. Okay, see there now. I can also add what's that here. I'm trying to add this println here. Even you can try this also while iterating each element with this for loop. You can also implement a business logic inside this. I see sometimes in our code this for all or for each is used, where not just these 3 lines. I see sometimes they implement a lot of transformations internally in this for each itself. This map function. Okay, I see in the code people using all such transformations internally, not just map, some other, even filter, even that flat map. Okay, and there's many more like that. Group by, even they apply sometimes group by. I see that in this for loop. Let me test it, sir, and see how it is going to show us results. But anyhow, we can expect what happens in every case. All of you are clear in this? Anybody has any yield is somewhat working like a map. It's not like map, Sandeep. It acts as like a buffer. When you put yield, it acts as like a buffer. Map, it doesn't work like map. In fact, for is something internally more like what is that is internally map has some kind of iterator like for. Yield is just a kind of buffer, so that until you extract all the elements, when you iterate all this for, each element is kept in the buffer, and that is finally initialized to this I. That is written. Got it right? Okay, it is not map. It's not like it acts as an internal buffer. That's what yield does. Okay, let's run this, sir, and see. Instead of using println, let's put print, sir. It's easy to see the outputs for us. Okay, I'm using println because these are iterating and giving us the results, right? Okay. Now let me run this. That should be much more clear for us here. Now, if you see this, but one thing is necessary. This is printing 1, 2, 3, 4, 5. The first one. Okay. After that, put one println for style 2. Just a simple println. No need of any data in that. After this, one more. After this one more, after this one more, after this one more, just to get proper formatted data for better analysis. Now you can see this is giving this is from external for loop. That is one thing. From here, second style 2 is from where when you use yield on that, you can see what yield is doing now. It is taking all the data. When you apply for loop, what's happening in the second case? Usually when you apply for, what happens? Every element is iterated and we do something on that. But what yield is doing? It is using temporary buffer. And what it is doing is that data from the temporary buffer again written back to the list. If you see here, it is written back to the list if you observe carefully. And by default, list is immutable, sir. We don't have mutable list anymore. There is another equivalent collection or data structure in mutable collections. Okay, list is only one time. That's always mutable. Okay, next, this is from R2 is again same thing. We are doing into you have multiples of 2 here, and third time we are doing subdivision. We got reminders, and fourth time we are just applying normal for loop again. You can see that the first one and this one is almost same. Again, after that, the last one, we're trying to increment by 100. Let us see what this is giving us. Where is this last one? That 100 thing is not working. Okay, I got it. What this is doing now, we will do one thing then. We will say val some result 5 or 4 equal to this one. Leave this print here. Let's not apply this print. Now let's run this. And of course, I need to print R for one. Print ln of R4. Let's run this now. We are getting empty tuple. Probably let me try to put it in only. Still empty tuple. So let me do one. Okay, this should work if I am not wrong, but let me just try it. No, this is also not working. Can take like this. What I am doing is incrementing each element by 100. Okay. What is this? I is taking actually. It's taking integer. It is incrementing, but I need to print it. If I should print it. Yeah. So what's happening here? For every element.
It's just printing 1, 2, 3, 4, 5.
Correct. So I'm just so it is taking parameter and incrementing it by 100. That's happening. That is the expression. And but still that result has to be preserved. Okay, when I do this lambda here, so I can do one thing then if that is the case. It's taking integer, right? It's not list even. If I should apply map or something, so directly apply okay, this should work. Got it? Do you understand, sir? Even that, my only point is to show that we can also do some kind of logic can be applied internally while iterating. Not just this. Still, we can make more complex scenarios. Okay, I'm just only showing you a simple use case here. Is it clear for everyone, sir? 1 minute, sir. I think we are successful. This is what I just want to show you. This is not just for it, just not only does only iteration. Internally, we can also apply some kind of transformations just to show that I have take to I use the simple use case. Okay, but we can take more complex scenarios. Anyhow, there is a long way for us. Definitely, by every day we see much more complex scenarios, and also tomorrow I'm very much excited on Bharat Sort by because I see that that's have a lot of potential to bring in so many things. Also, it gives an opportunity for us again to recap case class, and also it gives us an opportunity to recollect all the list related, and also it gives an idea how to add objects to a list and how to iterate those objects, and again how to apply sorting on objects in a list. Objects means not like this int float, this customized user defined objects like employee, like customer. How hello, can you hear me, sir? Yeah, I
Yeah,
lost
we can.
the no, I forgot to switch on the this thing. Okay, fine. I think this is clear, right, sir? All of you? All of you are good, sir? Please, can you confirm yes or no? Yeah. We will keep doing many more complex scenarios. Slowly, what happens is we get in touch with everything. So it becomes much more easier by the time we get to the Spark. It doesn't take much time. I am thinking within next 2 weeks we'll jump to the Spark. But before that, if you practice as much as possible in corrections, that is going to help you a lot in Spark, because this is the heart of your Spark or Java or C Sharp, whatever it is. Okay.
Bro, can you go and place cursor that for each?
Sure, sure. For each. Which for each you want in the internal one?
Yeah, the return type it is unit, so it won't give any so results back. We cannot capture
Correct.
that results.
Correct, correct. I agree. I didn't check that, Madhu. That's true. There is no meaning of returning any value from this, and also that's why you are getting, right? I tried to print R4. Yes, this is not a valid. This is not recommended. Probably I thought it returns. Okay, correct. If anything has to be done, it has to be done internally, or we can initialize that result to some variable internally. That is also there. We can preserve that into some temporary variables, maybe declaring them externally. Okay, correct. So as we know that unit method don't return result, it is not right to assign it. Thank you, Madhu, for correcting me. That's okay. We can also check like this, sir. Whenever you have any doubt on some method, whether it is returning or not, no, this is the best way. And this for then definitely these methods we have to apply on this, because this is an independent iterator. We don't need that. But I think apart
And
from this, yeah, is everything clear, sir?
it's clear. We are using for each, right?
Correct.
Instead of that, also we can use the yield method and print the same, right?
Yeah, this is for returning. If you want to extract the data and return it, then yield is recommended.
Okay.
This
That is
is
for printing also we can do.
yeah, you can see that for printing also you can try that. You can see there when you apply yield there, you can see there is a difference in the that return type there. Okay, this is actually, you can see, sir, what this is a regular for, and when you pass yield, what happens, sir? This is how we can what is that on for, if you want to return result, we can apply like this. Yield is best choice, correct? And you can see it's clearly saying it's see, read the statement here. When I put cursor on yield, build a new collection by applying a function to all elements of this list. Means what? From the iterator, it will build a new collection and put all the elements into that, and that collection is returned. So that is why here we are able to assign that result to this reference variable, and here we are not able to apply that. And second thing is we have to see whether we can put yield in this scenario, because this is coming from inside, right? Not from outside. This is not external for whether this is allowed or not. We have to again cross check it once. I'll check and update in tomorrow's session, Bharat. Okay.
Okay, thank you, sir.
Is your question answered, sir, or still am I missing anything?
No, it's answered. I got it.
Okay. So let me. I have a doubt again from your question. I got a question again. Can we apply yield on this implicit for, which is part of list or vector or any other methods? I will also just check that scenario. Okay.
I just checked in and raised that question.
Okay. Okay. Then I will discuss this in next session, sir. Tomorrow's session. Okay.
Okay, sure. Thank you.
Yes, sir.
Good night, sir.
Any questions, sir? Any more questions from anyone? Okay, we will close the session here, sir. We'll again discuss tomorrow. That sort by thing, we will come up with one beautiful use case. Okay. Thank you, sir.